Hi everyone, welcome to lesson 4 of our polynomials unit. Today's lesson is about equations and graphs of polynomial functions. Before we get into today's lesson, we're going to start on our opener question. So this question says to factor y equals x cubed, this equation here, and determine the x and y intercepts and sketch the graph as well. Okay, so for the sketch, just try your best to sketch whatever you can do. So for factoring, very first thing I'm going to do, go straight to my graphing calculator. On my graphing calculator, I already have y1 typed in and y2 equals 0. I'm going to hit graph right away here. I see 1, 2, 3. I see 3 lines there. I don't see my full graph, but more or less this should be okay in terms of factors. I'm going to go second trace, option 5 here, and I'm going to look for this very far left x-intercept first. So 1, 2, 3. There you go. So you have an x-intercept at -6. So let's quickly jot that down. So in this question here, we're going to start off with x equals -6. And the other two that we have looks to be at x equals 4 and 5 respectively. And again, you could use your graphing calculator to find that. But again, you could just read it off of your calculator as well. So I got x equals 4 and x equals 5 as well. So because I found my x-intercepts all on my graphing calculator here, I'm just going to go right into the factoring. And by the way, this is going to be my graph that I am more or less trying my best to sketch. Because this window, the graph here that they gave you was a 10 by 10, so we're just matching up, and this is everything that you would see on a 10 by 10. So right away, again, as mentioned, because I know my x-intercepts, I'm going to go right into factoring. I know that any of these would have worked if you subbed in, let's say, f at, or sorry, not f, if you subbed into your polynomial p at 4 there, into here, so what would we get? We get 4 cubed minus 3 times 4 squared minus, minus 34 there. 34 times 4 plus 120. There we go. If you added all these terms up, you'd end up with 0. So then this does show that x minus 4 is a factor. And because it is a factor, I can use then synthetic division to figure out, oh, what's my equation going to look like after the factoring. So again, I have 4 right here. My coefficients were 1, -3, 34 negative, -34, and 120 there. So again, bring down 1, multiply, 4, add, that's going to be positive 1, again, multiply, add, that's -30, and multiply, -120, and add, we get 0. So therefore, we have, for a partial answer, therefore we have x minus 4, and again this was x squared plus x minus 30 left over. And from here, you could definitely factor this using sum and product. So we would end up with x minus 4. Things that multiply to -30 add to 1 would be x plus 6 and x minus 5. And there we go. So we have our factors. From our factors, of course, to answer the questions at the top, so we factored fully. 2, determine the x and y intercepts. Well, again, our x-intercepts will be all of these right here. So our x-intercepts are going to be at 4, 5, and -6. And I'm going to just write that in increasing order there, ascending order. So we have -6, 4, and 5. Just like our graphing calculator had earlier, and our y-intercept here. Y-intercept, of course, is always that constant term at the end there. It should be 0, 120 for our y-intercept, and of course all of these should have also been written as ordered pair, but you can also list them off. And so that's our opener question for today. So going right into some notes here, so we have this note here that says positive and negative intervals. So what's going to happen on positive and negative intervals? A function is positive where it lies above the x-axis, and you're going to be negative when you lie below the x-axis there. So for this equation, and again, this is the exact same equation that we just graphed previously here. It's right here, and we factored it fully, so it's the same question, by the way. So it's asking you, for the function, identify the intervals where it is positive and negative. So basically, where in our graph is it above the x-axis and where is it below the x-axis? Well, right now I don't see my full graph. I do want to change my window settings so that I see something fully. I know that my y-intercept was around 120 there, so let's go something high like 150 for our max y's, and if you're doing that, you should probably change your scale. So right there, I almost see the top there. I am going to just play around with my window setting one more time here, just to see the top, so I'm going to change that to 250 instead. And there we go. That's our graph fully. So here on our graph, we're asking you, where in this graph is it going to be positive? Well, we're positive between this section to here. We dip down negative there, then we're positive again. So we were positive between, so we're going to be positive between, that value was from -6 all the way up to 4. Then we had a little dip underneath, but then that's okay. And then we were positive again from 5 going off to positive infinity. There we go. In between, again, I'm using interval notation. I'm going to put the letter U, meaning that I need both parts here. On the same graph, we're asking ourselves, where is it negative? Well, we're negative after -6 there, and in this bottom section. So going back here, so we're going from negative infinity all the way right up to -6 there, including -6. That's when we're negative. And the only other section where we were negative was right between 4 and 5. And there we go, between 4 and 5. Write the following in interval notation. We've done this before, so again, no equal signs, meaning rounded bracket. So we have rounded bracket 5, 10, rounded bracket. So we're looking between, for this x, between 5 and 10. Here, if x is less than -1, so that means we're going from negative infinity all the way right up to -1, including -1, because I see that equal sign underneath, so square brackets. On this one here, if we're including -2 because of that equal sign there, square brackets -2, all the way up to 7 does not include, so rounded bracket right there so that we can say it does not include. On the next slide, we're going to talk about this idea called multiplicity. Multiplicity is basically how many times a 0, aka an x-intercept, of a polynomial occurs in the function. So if you had a polynomial and it looks something like this, and this is already in factored form, this has a multiplicity of, and so the first blank here that we're looking for has a multiplicity of 3, because there's 3 x minus 2's. So it's going to be, has a multiplicity of 3 at x equals 2. And again, how did you get x equals 2? We just moved that 2 to the other side. Because the factor x minus 2 occurs 3 times, this is considered to be odd, because 3 is an odd number. Vice versa, this one says it has a multiplicity of 2, because we have 2 of these, 2 at x equals -2, because the factor x plus 1 occurs, or sorry, x minus 1, because the factor x plus 1 occurs 2 times, making this even there. Okay, so that's multiplicity in a nutshell. Again, it's just how many factors do you have? If they're the same, that's basically your multiplicity of how many times it's occurring. So just a few examples here. It says graph the following and determine the rules that relate to multiplicity. What would have a multiplicity of 1? And I'm going to do everything in terms of, so my base graph here. So my base graph is going to be x minus 3. So if I had a base graph of x minus 3, so 1, 2, 3, I'd have a graph that kind of looks something like this. It's just a straight line going straight up there. And this would have a multiplicity of 1. Because if you connected your dots here, forms a straight line, and we're only crossing our x-axis one time. And I'm just going to change color and make it just slightly thinner so that you can see our coordinates. There we go. And of course there should have been arrowheads on each end of this as well, just to finish it off. And that looks about good there, going through our lines. So arrowhead, arrowhead. And so here, I'm just going to write down the equation. This is going to be x minus 3, and that's going to be our first equation here. Just equation of a line, multiplicity of 1. Because right at 3 here, if you basically zoom in to this section here, that's a straight line right around x equals 3. If you have a multiplicity of 2, let's do this one here. So again, same graph. Let's do x minus 3 as our base graph, but this time we're going to square it because that's going to be a multiplicity of 2. So what does that mean? That means we shifted everything 3 to the right. And our graph looks something like this. It's going to be our parabola going up, shifting it 3 to the right, arrowhead, arrowhead there, okay? And there you go. And again, the section I'm looking at, you don't necessarily need to look at the full graph. You're always looking around that x-intercept, so I'm just going to kind of box around that x-intercept there. And you always want to look at that little section there, almost between 1 or 2 point values away. What does that look like at that x-intercept? Well, at this x-intercept, it's a parabola, so it's going to be degree 2. Degree 3 at that exact same x-intercept, and again, I have x minus 3, and this time we're going to go cubed on it. So degree 3, let's find our x-intercept again. Here we go. And it should look something like this. It's going to go up, and it's going to go down. So it's going in different directions. And again, this is going to be degree 3. This one here was a quick sketch. I didn't actually use actual coordinates, but again, you're looking for something that goes down and goes up. That's going to be degree 3. Degree 4 at the same equation, so we got x minus 3 to the exponent 4. What's that going to look like? So right around here, you're going to have a bit of a flatter line on either end, and it's going to go up. So it's more of a squared off parabola going up. And again, that's going to be degree 4, and how do you know? It's going to go a bit more squared off, and then it's going to go up, compared to here where it's more or less like a V or a U shape, more so a U shape than anything, and it goes up right away. And of course degree 5 at 3 there, and again we're going to go a bit flat here, and then it shoots up, and then it's going to go a bit flat line here, and it's going to shoot down for degree 5. And again, I'm always looking around that low range. Again, if you want to graph this on your graphing calculator just to see it a bit better, by all means you can. I would change your window back to 10 by 10. So again, if I had x minus 3 as my base graph, here's what it's going to look like. There you go. There's our straight line. Let's change that up now. Let's go with exponent 2 or squared. So there we go. That's my squared graph. Let's go cubed. And so there we go, that matches up. So again, there's that quadratic not quadratic, cubic function. So half of your parabola going up, half going down, going in different directions there. If you had exponent 4, what's it going to look like? Exponent 4 is going to be a bit more flatter compared to your parabola, and it goes flattens out there. And of course, the last but not least, let's double check exponent 5, see what it looks like, and there you go. Exponent 5 is going to be a bit flatter, almost a whole unit away, flatter, and then it starts changing and twisting away. So there you go, that's all 5 graphs. So things that again you need to know, take a look at end behavior 1, 3, 5, opposite directions for your arrows, 2, 4, and if there ever was a 6, same direction for your arrows. In this example here, we're asking you factor the following, complete the table that's below here. So we have a little table below there that we want to fill in. Sketch the function as well. It says without using a graphing calculator, but again, you should always use a graphing calculator first just to double check to see if it even works. So right away, I'm typing into my graphing calculator 3x squared plus x, or sorry, that's x cubed plus x squared. There we go. Minus 8x and minus 12. If I graph this right away, I'm looking at degree 3 polynomial, so I have potentially 3 x-intercepts right now. I only see 2. I'm going to add in a 0 there, by the way. I see definitely 2 x-intercepts. I see one right here and then another one right here. One right here is going to be at x equals negative 2. Here it's going to be at x equals positive 3. So I'm going to write down my x-intercepts right away. So x, I have x equals, what was that? That was negative 3. And, sorry, that was negative 2 and x positive 3. There we go. X negative 2, x equals negative 2, and x equals positive 3. And again, you could have just combined that, but I'm just going to write it separately for now. If I know one of these guys are my factors, I'm just going to go straight into factor theorem. So if you had your polynomial, if you subbed in 3 into the polynomial, you're looking for 0. It does work out. Therefore, x minus 3 should be a factor. If it is a factor, then you go straight into synthetic. And so I'm going to show the full workup for synthetic and not so much for that first part there. So if you had 3 here, and again, what are coefficients? I got 1, 1, negative 8, and negative 12. Those are my coefficients. Dropping down, multiply, add, multiply, add, and multiply, and add. And there we go. So we have x minus 3 with x squared minus 4x minus 4. And again, can you factor that fully? Of course you can. So we're going to have x minus 3. Then you have this x plus 2. And, sorry, these should have been positives. Each x plus 2 and another x plus 2. There we go. So we have our equation factored fully, and if you took a look at our factored equation, you have multiplicity of 1 right at 3 there, so it should look more so like a straight line, and you have the same factors here twice. So at negative 2, you're looking more so at a parabola shape there. Okay, and let's jot down a few things. So if I have my 2x intercepts right there, I'm going to also incorporate this y-intercept. Y-intercept is at negative 12, so negative 12 is going to be down here. So we want to cross our y-axis somewhere down here. And if you take a look back at our graphing calculator, it's going to be down here. So let's make our window a bit bigger so that we truly see it. We want more negatives, so I'm going to go negative 20. Negative 20 should work. Hit graph, and there we go. We see the bottom of our graph there. And I'm going to try my best to graph the same thing here. Let's pull off a few extra coordinates here. So second graph brings you up a table of values, and you can use any of these coordinates. So again, at negative 2, I'm at 0, so I'm going to use negative 1, negative 4 as a coordinate there. So negative 1, negative 4 is right around here. Of course, we pass through that other coordinate, negative 3, negative 6, because that fits on my grid here. Still negative 3, negative 6 is right here. So right away I'm going to start connecting my dots. They're going to go something like this, and it shoots straight down. And here I'm connecting these coordinates right here, going through that y-intercept, of course, at 0, and then I'm at 1, negative 18, 2, negative 16. So at 1, I'm at negative 18, which is just a bit further down on my graph here. So 1, negative 18. And at 2, I'm at negative 16. And at 3, I'm already back up there. So I'm shooting all the way back up there. So again, I'm going to just try my best to connect my dots to these guys here. Shooting back up. And there we go. This is more or less our graph. And let's see if we have anything at 4. 4, can we graph it? It's off the grid. It's 36 there. So it's off the grid. So I'm just going to extend that just a bit slightly. And there we go. That's our graph sketched. Quote unquote, very, very rough sketch. Let's fill in some of these here. So if you take a look at our equation, the largest degree was degree 3. The leading coefficient on it was 1. That means our end behavior went from quadrant 3 to quadrant 1. So we were negative, and we went in the positive direction, and our y values there are positive. What are our zeros, x-intercepts, or roots? All three are of those keywords all mean the same thing. So we only have two of them. We have x equals negative 2 and x equals positive 3 as our two zeros or our two roots, our two x-intercepts, all three are the same. What's our multiplicity? So let's jot this down. So we have a multiplicity So let's start with this negative 2 first. Multiplicity of, and how many x equal, or x plus 2s did we have? We had two of them, so multiplicity of 2 at, and that was at x equals negative 2 because we had two of them. And the next one would be multiplicity of 1 at x equals 3 because you only had 1 at x equals 3. What's our y-intercept? Of course, it's going to be our constant term. It's just going to be 12. And we'll take a quick break here, and then we'll start the next batch here in 30 seconds.